Your next quiz covers your lessons 5.1 through 5.3. Something that's not on your review that is on your quiz are those right triangle word problems. So make sure that you take a look at that practice worksheet that was focusing on those word problems with your right triangles, and go over that. Your answers for that are up. So again, make sure you use that to study from as well, because you definitely will have a question on your quiz that pertains to that. We're going to start with your review from converting from radians to degrees and from degrees to radians. If you're going from radians to degrees, you're going to multiply that radian by 180 over pi. If you're going from degrees to radians, you're going to multiply the degrees by pi over 180. So if we look at number 1, we have negative 7 pi over 5. It's a radian. We're going to multiply it by 180 over pi. Your pi cancels out. Your 5 goes into 180 36 times. We multiply negative 7 times 36, and that gives us negative 252 degrees. For number 2, we have 2 pi over 5. So we're going to multiply this by 180 over pi. Your pi's cancel. Your 5 goes into 180 36 times. We do 36 times 2, and that's 72 degrees. For number 3, we're working with 645 degrees. So we're going to put that 645 over 1 and multiply it by pi over 180. Your 180 and your 645 are both divisible by 5. That 645 is going to turn into 129. That 180 turns into 36. 129 and 36 are both divisible by 3, so that 129 is going to become 43, and that 36 becomes 12. So we have 43 pi over 12. For number 4, you have negative 1,205 degrees. So we're going to put this over 1, multiply it by pi over 180. We are going to divide the 1205 by 5. Same thing with the 180. We know the 180 turns into 36, and the negative 1205 turns into a negative 241. There are no factors that are like factors between the 36 and the negative 241. So that's going to give you negative 241 pi over 36. For your next section, you are finding the reference angle for each of the following. Now, these are given to you as radians. So you're going to want to change your radians to degrees and then work with the degree. Remember, your reference angles are positive acute angles. So they have to be less than 90 degrees and they have to be positive. So the first one that we're going to look at is number 5. Number 5 gives us 16 pi over 5. Change it into a degree, multiply it by 180 over pi. Your pi's cancel. Your 5 goes into 180 36 times, and 36 times 16 gives us 576 degrees. Now, this 576 is not within 0 and 360. So subtract 360 from it to get a smaller angle measurement than 360. This would give you 216 degrees. This 216 degrees is in quadrant 3. So you are going to take that 216 and subtract 180 from it. That 216 minus 180 gives you 36. So now turn the 36 degrees back into radians. If your question is given to you in radians, your answer must also be in radians. So we're going to put this 36 over 1, multiply it by pi over 180. We keep saying that 180 divided by 5 is 36. So this 180 is going to turn into 5. This 36 turns into 1. We multiply straight across, and we get pi over 5. For number 6, we have negative 2 pi over 3. So we're going to turn this into degrees. We're going to multiply it by 180 over pi. Your pi cancels. 3 becomes 1. 180 becomes 60. So negative 2 times 60 is negative 120 degrees. Yes, this is negative. However, If you add 360 to this, you are going to get 240. You can then work with that and subtract 180 from it because that one is in your third quadrant as well. And that's going to give you 60 degrees. That 60 degrees is your acute angle. It is positive as well. So turn that into radians. Put it over 1, multiply it by pi over 180. You can turn the 60 into 1, the 180 into 3, so that gives you pi over 3. The good thing about these negative angles is you can also take the negative 120, turn it into a positive, and subtract it from 180, and it still is going to give you the 60 degrees. Again, these reference angles are positive acute angles, so it has to be a positive angle. That's your answer. So either you can continue to add the 360 until you get the positive acute or the positive angle, or you can say, okay, then 120 is less than 360. If I turn it into a positive and then subtract it from 180, that gives me my 60-degree angle, which is an acute positive angle. I can work with that to turn it back into radians. For number 7, you're starting off with negative 28 pi over 3. We're going to multiply this by 180 over pi to turn it into degrees. Your pi's cancel. Your 3 cancels with your 180, which turns into 60. We're multiplying negative 28 by 60 to give ourselves a negative 1,680 degrees. So that is the equivalent of the negative 28 pi over 3. You want to turn this into a positive angle first. So add 360 to that number enough times to turn it into a positive. So add 360 to this. You are left with negative 1320. Add 360 to that. You are left with negative 960. Add 360 to that. You are left with negative 600. Add 360 to that. You are left with negative 240. You're still negative. Add 360 to that. You're left with 120. That 120 degrees is in quadrant 2. So take that 180, subtract 120 from it. You're left with 60 degrees. Turn the 60 degrees into a radian. Lucky for you, you did that in number 6 already. So it's just pi over 3. For number 8, you are given that cosine theta is equal to negative 5 over 8. The tangent of theta, the same theta, is greater than 0. Cosine is x over r. So if this x over r is equal to negative 5 over 8, the r is always going to be positive. The x is going to be the one that's the negative. So that negative goes with the 5. So x is negative 5. Your r is positive 8. X equals negative 5. Y, you don't know yet, but the r is equal to 8. From here, it tells you that tangent of theta is greater than 0. Tangent is y over x, and that's greater than 0, which means it's a positive. And if y is what we're finding, and x we know is a negative number, what's going to be the sign on the y in order to turn that fraction into a positive number? Negative. So we know that our y is going to be a negative number. You still have to find y though. I like using a squared plus b squared is equal to c squared. If you'd rather use r is equal to the square root of x squared plus y squared, you can do that too. So instead of a, it's going to be x. Instead of b, it's going to be y. Okay? So this is going to give me negative 5 squared plus y squared is equal to 8 squared. The negative 5 squared is 25. The 8 squared is 64. Move your 25 over. subtract it from both sides, you're left with y squared is equal to 39. Take the square root of both sides, and you have that y is equal to the square root of 39. However, we said that y has to be negative, so it's the opposite of the square root of 39. Now that we have x is negative 5, y is the negative square root of 39, and r is equal to 8, you're going to find sine, cosine, tangent, cosecant, secant, and cotangent. Remember, sine is y over r, so if we put y over r, that's going to give us the negative square root 39 over 8. You don't have to do anything with that. You can leave it just like that. Cosine theta is x over r. It's already given to us in our question, so we're just going to rewrite that as negative 5 over 8. If we know cosine, we know secant because it's just the reciprocal, so secant is negative 8 over 5. Tangent is y over x. If tangent is y over x, that means that's the square root of 39, the negative square root of 39, sorry, over negative 5. A negative divided by a negative is a positive, so that's just the square root of 39 over 5. Find your cosecant and your cotangent still. For your cosecant, you're going to flip that, so it's going to be negative 8 over the square root of 39. Can you leave a radical in the denominator? No, you can't. Multiply the top and the bottom by the square root of 39. And that leaves you with negative 8 square root 39 all over 39. Find your cotangent. Your cotangent, however, is x over y, not y over x. So you might want to change that. So this is x over y. So this is going to give us x, which is negative 5, over y, which is negative square root 39. Negative over negative turns into positive. We multiply top and bottom by the square root of 39 to rationalize that denominator. And that gives us 5 square root 39 all over 39. For your next section, you are finding the area of each of these triangles. Now, your original file of your review has an error in the formula that you use for the area. The error is the function that you're using. The correct one should be your two side lengths multiplied by one another times the sine of your angle, all divided by 2. So on your form, just make sure you change that cosine to sine, because it should be sine. For 9, you're given that your angle measurement A is 30 degrees. Side B is 15 inches and side C is 5 inches. So if we use our formula, we are going to have the area is equal to 15 times 5 times the sine of 30 all over 2. So 15 times 5 times the sine of 30 all divided by 2 is 18.75. If we round this to the nearest unit like it tells us to, this is going to be 19 inches squared. For example 10, you're given that your angle measurement B is 10 degrees, side A is 4, and side C is 7 feet. We're going to do the area is equal to 4 times 7. So this is all multiplied by sine of 10 all over 2. So once you put that into your calculator and hit enter, you get 2.4310 whatever. So if you take that 2.43, you round it to the nearest unit, you're going to get 2 feet squared. Your next part, you're going to find one positive and one negative coterminal angle for each of these. Remember, the form in which your question is given to you is the form that your answer has to be given in. So if it gives you your question in degrees, your answer should be in degrees. Same thing with radians. If it's given to you in radians, your answer should be in radians. For number 11, you're given 423 degrees. So we're going to take this 423 degrees and we're going to add 360 to it. That 423 plus 360 gives us 783 degrees. That one is just your positive coterminal angle. You still have to find your negative coterminal angle. So take the 423 and subtract 360 from it until you get a negative number. 423 minus 360 gives us just 63 degrees. So you still have to subtract 360 from that to give yourself that negative 297 degrees that you're looking for. So again, one of these answers should be positive, one of them should be negative. For number 12, you have negative 197 degrees. So you're going to take that negative 197 and you're going to add 360 to it. The negative 197 plus 360 gives us 163 degrees. So that one's a positive number. That's your positive coterminal angle. Next, you are going to take the negative 197 and subtract 360 from it. So negative 197 minus 360 gives us negative 557 degrees. For number 13, you have 7 pi over 3. So 7 pi over 3, you can either turn it into degrees and work with the degrees, or you can keep it as radians. If you keep it as radians, you're going to add and subtract 2 pi to that because 2 pi is equivalent to 360 degrees. So if we take that 7 pi over 3 and we add 2 pi to it, remember that 2 pi is over 1, you need like denominators. Multiply top and bottom by the 3 to give yourself 7 pi over 3 plus 6 pi over 3. Denominators are the same. Add your numerators, keep it over the 3. That gives you 13 pi over 3. That one is your positive. So next, find your negative. Take the 7 pi over 3, subtract 2 pi from it. We said we multiply top and bottom by 3. So this is the same thing as 7 pi over 3 minus 6 pi over 3. This only gives you pi over 3, which is not a negative radian. So you need to continue to subtract that 6 pi over 3 from it in order to get that negative radian that you're looking for. So you have like denominators here. Subtract your numerators. That gives you negative 5 pi over 3. You have that negative angle. You have that positive. You have both the ones you're looking for. Now, something that you probably weren't aware of is that any positive angle that you get when you add 360 to that, or 2 pi, to that 7 pi over 3, is considered a coterminal angle. So that pi over 3 is a positive coterminal angle as well. So you could literally give me both of them, like either one. So either the 13 pi over 3 or the pi over 3. It's up to you. But they're both positive coterminal angles. For number 14, you are given 26 pi over 5. So for this one, we're going to take the negative 26 pi over 5, and we're going to start by adding 2 pi to it. Remember, it's the same thing as 2 pi over 1. So you multiply top and bottom by 5. You get negative 26 pi over 5 plus 10 pi over 5. When you add these on the top, you're left with negative 16 pi over 5. That is not a positive radian. So you can literally take this negative 16 pi over 5 and tell me that that is one of your negative coterminal angles. That's fine. So you wouldn't have to subtract the 2 pi over 1 from it. Okay? But if you want to keep going with this, which we do because we want to find a positive coterminal angle, we're going to add that 10 pi over 5 again. And that gives us negative 6 pi over 5. So that's another negative coterminal angle. Okay? So still add that 2 pi or the 10 pi over 5 to that. And that finally gives you 4 pi over 5. So your positive coterminal angle is at 4 pi over 5. If you wanted to, you can tell me that that negative coterminal angle is either negative 6 pi over 5 or negative 16 pi over 5, as long as it's not the original radian. If you're not comfortable doing that, you don't have to. You can still take that negative 26 pi over 5, oops, maybe 26, not 2, 26 pi over 5, and subtract 2 pi from it. This is going to turn into negative 26 pi. Why do I keep doing that? 26 pi over 5 minus 10 pi over 5, which gives you negative 36 pi over 5. So literally, for your negative coterminal angles, you can give me any of those three negative radians. The negative 16 pi over 5, the negative 6 pi over 5, or the negative 36 pi over 5. But your positive coterminal angle has to be a positive, so that's going to be that 4 pi over 5. For your next, all right, so your next question, you're finding the exact value of all 6 trig functions given this triangle, this right triangle. So we know that on your right triangle, the side length that is across from your right angle is your hypotenuse. The side length across from your theta is your opposite, which means the only one left that you're missing is your adjacent. You don't know what that adjacent is, so find it. Use your a squared plus b squared is equal to c squared and just solve it. So you can use x squared plus the square root of 5 squared is equal to 6 squared. This gives you x squared plus 5 is equal to 36. Subtract your 5 over. You have x squared is equal to 31. Take the square root of both sides. Even though you're working with an equation, you're dealing with radicals. Side lengths are positive, so it's just going to be the positive square root of 31. So your opposite is the square root of 5. Your adjacent is the, here, let's do it this way. Opposite is the square root of 5. Adjacent is the square root of 31. And your hypotenuse is 6. Your sine is opposite over hypotenuse. So that's going to give us the square root of 5 over 6. Your cosecant is the reciprocal of sine. So that one is hypotenuse over opposite, which is 6 over the square root of 5. You multiply top and bottom by the square root of 5. Simplify this. And this gives you 6 square root 5 over 5. Your cosine is adjacent over hypotenuse. So that one is going to be the square root of 31 over 6. Your secant is the reciprocal of cosine. So that's hypotenuse over adjacent. So that one's going to be 6 over the square root of 31. You multiply the top and bottom by the square root of 31. And that gives us 6 square root 31 all over 31. For tangent, you have opposite over adjacent, So that one's going to be the square root of 5 over the square root of 31. Rationalize your denominator. Multiply top and bottom by the square root of 31. And that gives us 31 times 5 is 155. So the square root of 155 over 31. For your cotangent, again, reciprocal of tangent, so adjacent over opposite, means that you're going to have the square root of 31 over the square root of 5. Rationalize your denominator, multiply top and bottom by the square root of 5, and that just gives you the square root of 155 all over 5. For your next section, you're dealing with arc length and area of a sector. Remember with these, your theta has to be in radians. So this gives you that theta is 145 degrees. So you have to turn that into radians to begin with. That 145 is over 1, so we're going to multiply it by pi over 180. 5 is divisible by both the 45 and 180 are both divisible by 5. So the 145 becomes 29, and the 180 becomes 36. So this is 29 pi over 36. Your radius is that 7 centimeters. So if we're finding the arc length, we're working with S is equal to R times theta. S is your arc length, R is your radius, and theta is in degrees. Or sorry, in radians, not degrees. So this is going to give you S is equal to 7 times 29 pi over 36. 7 and 36 do not share a common factor, so multiply straight across. 7 times 29 gives you 203. So that is 203 pi over 36. Now, this is in centimeters. So when you do this, it may or may not tell you. If it tells you to keep your answer in terms of pi, you can leave it like this. However, if it tells you to round your answer to the nearest unit, you're going to want to actually use your calculator and simplify this. So if we plug this into our calculator, you're going to have 203 pi divided by 36. You should get 17.715, so on. If you're rounding that to the nearest whole number, that gives you 18 centimeters. So again, it just depends on what your question asks you for and what unit of measure your answer should be in. If we look at finding the area of this, your area formula is A is equal to your radius squared times theta in radians all over 2. So this is going to give us A is equal to 7 squared times 29 pi over 36 all over 2. That 7 squared is 49 times 29 pi over 36 all over 2. Remember, your fraction means division, so you can write this as a division problem as well. So when you multiply that 49 times 29 pi, it's going to give you 1421 pi all over the 36, because remember that 49 is like 49 over 1. So if we write this using division, it's just the 1421 pi over 36 divided by 2, or 2 over 1. To divide fractions, keep, change, flip. So this is going to give you the multiplication of 1/2. Multiply straight across, since you do not have anything that you can simplify. And this gives you 1,421 pi all over 72. Again, if it asks you to write your answer in terms of pi, you would leave this as your answer. However, if it asks you to write your answer rounding it to the nearest unit, you're going to get 1421 pi divided by 72 is 62.0028-ish. If we're rounding to the nearest whole number here, and you're working with area, that means your area is 62 square centimeters. So the only thing that's not on your review, other than those right triangle word problem that is noted at the very top, is finding the quadrants. So okay, so when you find the quadrants, if you have something like sine theta is greater than 0 and cosine theta is less than 0, you got to find out which quadrant your theta lies in. So sine, we keep saying, is y over r. If y over r is greater than 0, it means that that's a positive number. We know r, automatically positive. In order to make sure that fraction is positive, y then also has to be positive. So from here, cosine is x over r. Well, cosine is less than 0, which means it's a negative number. If cosine is a negative number and we said automatically that r is positive, in order to make that fraction a negative, x has to be negative. So look at every part that you have, your x, your y, your r. X has to be negative, y is positive, r is positive. Your r is irrelevant. When you're looking at ordered pairs, it's x and y. So the only thing you need is the fact that this x is negative and this y is positive. In your quadrant 1, you have a positive x and a positive y. Quadrant 2, you have a negative x and a positive y. Quadrant 3, they are both negative. In quadrant 4, your x is your x is positive and your y is negative. So which quadrant do you have a negative x and a positive y? Quadrant 2. So this theta lies in quadrant 2. A second example like these, let's say you have cosecant of theta is less than 0 and cosine theta is greater than 0. Cosecant is the reciprocal of sine, so that's r over y. Well, r over y, we're told, is less than 0, which means it's a negative number. We have r in there, so we know automatically r is positive. If r is positive, in order to turn this fraction into a negative fraction, y has to have the negative. Work with your cosine theta is greater than 0 now. If cosine is x over r, and that's greater than 0, that means we're going to end up with a positive fraction. Which means we said r is automatically positive, x then also has to be positive. So again, identify everything that you have. You're working with a positive x, a negative y, and a positive r. We don't have to worry about that r because ordered pairs are just x and y. So you have a positive x and a negative y. Which quadrant is a positive x and a negative y? 4. Quadrant 4. So that's your answer.